I've seen lots of posts on Reddit where people are struggling to understand object oriented programming, the concepts, the conceptual value. And it surprises me because there's an amazing number of videos out on YouTube where, and some of them are really, really good, discussing, object oriented programming and how it works in Java and, how to do it. So I'm assuming then that probably there are just some things about object oriented programming that haven't been explained in a way that makes sense to you. So I'm going to take another stab at it and see what you think. So the question is, who is this for? Well, this is for absolute beginners. I mean, if you already know Java and you understand object-oriented programming, don't waste your time watching this video. This is not for you. But if you want to see object-oriented programming from just another point of view, then follow along. The key thing about this is, and what you have to understand about Java is that everything in Java is really about objects. Everything in Java is an object. There's no, global variables. There's no standalone functions. Everything in Java, every kind of thing belongs, it either is an object or belongs to an object. The code belongs to an object. The data belongs to an object. So using Java, you really need to get your head around this concept. And in Java, the way that objects are defined, the way that you tell Java what an object is, what's inside it, and what it can do, is with the class. And there are different kinds of classes, but the class is the main structure. So we're going to talk about how to do that in this video. All right, let's use OOP to start conceptualizing our application. Some people will go right to the code and start coding away, but I like to conceptualize and model and think about it first before I do it. So I usually use the drawing method. So let's go to it. So let's say that what we're going to create here is we're going to write software that's going to model your bank account. So let's talk about your bank account and let's just create our bank account. So here it is. So let's call it an account. All right, that's my account. Okay, so it's my bank account. So what are the things I can do to my bank account? A bank account is an object, right? It's a thing, right? And it has data inside it, okay? It's an object, so it has data inside it, and it has behavior. It has functions or quote-unquote methods that you can use to change the inside of this account, right? So what are some behaviors? What are some functions or methods that this object can have? Well, I can think of two right off the bat. So I'm going to try to draw them here. Let's use the arrow, right? And let's call this a deposit. And what do I need? What do I need to make a deposit? Well, I need the amount, right? So there we go. So there's my amount. So this is a function that can be applied, that can be put on. You can put on that and it will change this account, right? And then we can also do withdrawals, because after all, what good is an account if you can't make withdrawals? So let's change this to withdraw. Okay, there we are. So there we now have this object called an account with two methods or functions, right? One's called deposit to put money in, one's called withdraw to put money out. Two functions that take a single parameter of an amount, okay? That's pretty simple, right? So when this happens, when you go into this account object, what should happen when you call one of these functions, right? What should happen? Well, the balance of the account should change correctly depending on which of these functions you called. So that means the account must have some internal thing inside it that remembers the balance, right? The quote unquote the state, right? So let's create a variable in there, right? We'll call this the balance. Right? That's the latest balance. Pretty simple. And notice that it's inside the account, right? It's not out here No one out here can get to it, right? It's totally, the only way you can change this account is if you make a deposit or you make a withdrawal. That's the only way this balance can be. So that means I want to be able to see the balance. How do I see the balance? Well, I probably would have another function, which would be get the balance. Get balance, right? And that would give me back whatever's in this little balance guy. Okay, so that's one way we could model this, right? However, think about it for a minute. If you think about it, let's go slightly deeper into this, our model a little bit. So now we can make deposits and we can make withdrawals and we can ask for the balance, okay? But what's something we really, almost absolutely need to do with our bank account? Well, we need to see the individual, we need history, right? We need some history of what was done, right? So let's create history. So to create history, right, let's use one of these. Let's use this guy. This is kind of nice. And let's call this our history. And what is history? Well, it's just a list, right? All the history is it's a list of these transactions, right? And we probably would say that, they are in the order that they were introduced. Does that sound fair? This list keeps them in the order in which they were done. That way it's easy for us to go back in chronological history and see. Now, this list is an object. It's an object, just like everything else, just like an account. It is an object, right? And as an object, it's going to have methods. But the question really is this object out here floating around all by itself? Or does it make sense to have it be part of the account? Well, I think you can see pretty easily that it should be part of the account. So why should it be part of the account? What's a good reason for it to be part of the account? Well, the answer is it's because what if I have more than one account? What if I have 2 accounts? What if I have 10 accounts? What if I have an account and my wife has an account and my kids all have accounts? Well, I want the history for this account to be unique. I don't want to have all the history for all my accounts, in one same place, okay? So that means that this object, the account object, is going to have a history object. And this history object can take many, many forms, right? In our brain right now, it's just an ordered list is all it is. All right, let's do our first code. Let's start our code. I'm in Visual Studio Code, and I'm going to try to do this without using a bunch of project stuff. It may or may not work, but we'll see how it goes. So the first thing we're going to do is we're going to go over here to our Explorer, and we're going to add a new file. Let's create our first object, account. Right? So this is our first. And notice that Visual Studio Code is pretty smart, and it pre-populates a bunch of stuff, so you don't have to type anything. So what did we say we were going to have? Well, we said that our account was going to have a balance. So let's make a public double of a balance. Now, you can immediately think about some of the dangers of using a double to store a balance, especially since, there's all kinds of things around rounding errors, etc. And if you were writing a real banking app, you probably would not use a double. In fact, I've written banking apps for Chase, and they do not use floating precision arithmetic for doing mathematical computation. So just letting you know. All right, so there's our balance, right? Our account has a balance. Now we're going to create our functions, right? So we're going to create a function. And this function doesn't return anything, but we're going to do a deposit. And I apologize for my spelling. And of course, if I deposit it, then I'm going to say balance plus the amount. Seem pretty simple, right? And the withdrawal should be public withdraw. Oops, I need the void return type. Today. All right, so there is our basic account. It has a balance and it has two functions, deposit and withdraw. So let's test this out. Let's test our model out. Well, to test it, let's create another class. And this class is basically just going to serve to be our main driver, right? So let's create a new, and let's call it main. You can call it anything you want. It doesn't really matter, but I'm going to call it main just so we know it's main. And in order for Java to run, it needs a main function, right? So we are going to create a public static void main string array args. And the truth of it is, your IDE and even Visual Studio Code knows how to generate this function for you with just a few letters, but I'm going to skip that for now. All right, so what are we going to do? First thing we're going to do is I want to create one of these account objects that I've just defined. So to do that, we give it a type, account. I'm creating an account. I'm calling it account. And it is new account. So this is how I instantiate that object. Right? Now, what can I do with my account? Well, I can say account dot, and I can get, I can't do anything, right? It has deposit and withdraw, right? So I can say account dot balance equals $100. So now I've just set the balance of that account, right? And now I can say account dot deposit, and I'm going to deposit another $100.75, and I'm going to withdraw 75 and 25 cents. And now I'm going to print my balance. There we go. Let's see if we can run this. See over here, you got the little run button. Let's do a little run, and look at that. It says, hey, my balance is 276. It's probably 276. Computers, one thing computers are good at, it's math. Well, congratulations. You've already used object-oriented programming to build your first little program. Why? Well, because that's what Java does. That's how Java is put together. So now that we've done this, let's add some history, because we talked about history before. So let's go, and we're going to add another object inside public list of double, and I'm going to call it history. New array list. And notice here I'm losing this diamond operator, which basically just tells the compiler, hey, look at however I'm parameterizing this class here and just duplicate it. So the compiler knows. He knows what you mean, right? And now I'm going to go down here. So now whenever I add money, whenever I call deposit, I'm going to add that amount. And whenever I take away money, now I'm going to do something off here. I'm going to actually change the sign of the withdrawal, just because when you look at the list of amounts, I want to know that this is a withdrawal. All right, so far we've done everything. Now we've added history. So let's try to run main and see what happens. Are you ready? Here we go. And notice you get these nasty errors. Hey, the list cannot be resolved to a type. The reason you're getting those errors is because the compiler cannot find those classes. It's not in your stuff, right? You haven't defined list and you haven't defined array list, right? So you either need to create those classes yourself, or you need to use the ones that come with Java. Well, I want to use the ones that come with Java, with the JDK. So what I need to do is add the imports to tell the compiler where these classes live. Now, I could go through the docs and find it, but this is another benefit to using an IDE is it will do it for you, right? So we can go over here to this guy, and we can do command period, which is the quick fix in Visual Studio Code. And I can say, hey, source actions. And I can say, add missing imports. And notice what it did. It just added Java util array list and Java util list, which are the right ones. Those are the ones I want. So let's go back to main and see if our code compiles. And it does. See, now it's back to working again. What I'd like to do is write a function or a method that will dump out the state of my account. So let's go back to the account and let's create a new function. Public void. Let's just call it report. It's not very creative, but it is what it is. All right, so system.out.println quote report for account. That little %n, by the way, I don't know if you are familiar, that %n basically adds, because I'm using printf instead of println, printf doesn't imply a carriage return on a line feed or a new line. So you actually have to tell it, I want a new line. And then also notice here that I'm just using the word balance. I'm not saying account.balance. I don't have to, right? I don't have to clarify or qualify balance. It knows it's for this instance of the object. And let's print out the history. Let's call this history. Now let's say of. And to print a list is very simple. To iterate through a list is really just a for statement. For double note in history trends is to F%N. All right. Let's see if our code still compiles. So let's go over here to main. Let's run it. It does, but it's nothing different, right? So let's go back here. And let's comment this out. This time let's call account.report. Let's just call the report function. And let's run. And look what I got. Report for account, the balance, history of account. Trans 100, trans 7525. Okay, wait a minute. Something's off here. Something's not right. Something isn't right at all. This does not add up to this at all. Well, that's pretty easy to figure out. The reason it doesn't is because you see what I did here in main? In main, I actually forced a change to the balance. Main is outside the account, but it forced a change to balance. This is a huge problem when it comes to integrity of the class. So what do I want to do? How do I solve this problem? Well, the solution is I want to make it so that nobody from the outside can change balance. Only the account can change the balance. So let's make this private. right? I've now made balance private, and for that matter, I should make history private. I shouldn't let anyone else outside of the account make changes to this. Otherwise, I'm going to mess up the integrity, right? So let's go back over here now to main. And what's probably going to happen if your IDE is it's going to say, wait a minute, this field is no longer visible. I cannot, outside of anybody outside of account is not allowed to change the balance. So let's comment that out so that that's not happening. And now let's run our report. So now if what I want is to have an initial starting balance, what I need to do is add that here. So I need to say account dot deposit, 100. There we go. Now I should be back to the, I think it was 276. Yep, there we go. Now I'm back to the 276. So what I've done here is I've used the whole concept of encapsulation. This is where you take details of your class and you hide them, or you make them private so that people outside your class can't make changes to it without your knowledge. That way you have a chance to make sure that the state of your object is integral, that it's complete, that it makes sense. We've done a pretty good job here, but if we run our program, we get this nice little print, but wouldn't you like to know what this is and the date that it happened? Well, maybe we should add that functionality. Well, we can do that we could go to our deposit and withdraw methods, and we could add, we could add a string of, who or what, and we could add a date. I'm going to make it a string for now. We talk about date formats later, but so you could add that, and then you'd have to add that down here. Well, that seems a little bit complex. Wouldn't it be better if we turn this sort of collection of pieces of data about a transaction into an object? If you're going to think in an object-oriented way and code in an object-oriented way, that's probably the right way to do it. So let's go create a new class. So the first thing I'm going to do is I'm going to save this here, and I'm going to add all my changes, and I'm going to call this encapsulation. There we go. All right. Now I've captured my changes. Let's create a new object. So let's go over here and create a new file, and let's call this, let's make it short. Right? This is a transaction, right? Okay, so what does a transaction have? Well, it has private, double amount, and it has a private string what, and a private string date. All right, so here we have the bare bones of our object. Now, of course, I've made all these fields private using encapsulation, sort of the idea of encapsulation as the right way to do this. But once I do this, I can't make changes to this without some kind of a method. I need a function that lets me change it, because I can't change this from the outside. I can't say tx.amount equals. Once I make these private, it's not going to let me do that. So what we need is what are called getters and setters. Now the beauty of it is your IDE will do this for you. You don't want to learn to type this. There's no value in that. But I believe if we do, let's see, I'm going to look up the Visual Studio way to do this. I believe the magic key is Command period. And look at that. There you go. And let's go down here to generate getters and setters. So now that I've generated all these getters and setters, I can now call these methods on an object, on a new transaction, and I can set all those values. However, and I could do that. However, I would like a better way to, anytime I create one of these things, these transactions, I'm probably going to set all these values at the time that I create it. So that's done with the constructor. So let's generate a constructor. Let's see if the super will do it here. So command period, and I can say generate constructors. And let's say I want to do all of them. So I'm going to do all of these, right? And look at that. So now, once I have this, I can go over to my account. Actually, let's go to main. Let me see what the best way to do this is. All right, so we have created this new transaction. So now let's go change our account. And we're going to refactor our account to use the transaction object. So let's make some changes here. So on a deposit, we're not going to take a double. What we're going to take is a transaction. All right? And same thing on withdraw. Withdraw is going to take a transaction. All right? And now what I'm going to do is I'm going to start changing the body of this method. And you probably, I don't know that you can see it, but you notice how the IDE isn't complaining that I'm trying to change the balance with this amount thing. And I believe that's because we're using Visual Studio Code without the benefit of a project. Because what a project would do is project would tie all these files together in kind of one unit. And that way the IDE can look at all your code together as one and make decisions about what's right and what's wrong. We'll get to that. But for now, let's fix this. Let's just change this to TX, right? And let's get down to here and make this TX. And notice now it's complaining because it says, wait a minute, you can't get directly to amount. It's private. So you have to change this to get amount. And change this to get amount. All right. So now the question becomes, will my app run? Well, it probably won't, because if we go and look at the main driver, what have I done here? I'm calling deposit, but deposit takes a TX. It doesn't take a double anymore. So let's fix this. Let's make this a transaction. Now notice the IDE is trying to help you. It's suggesting that, hey, you know, this really needs to be a transaction, not a double, not just a number. So let's change this to a new TX, right? And I want 100, and I want James Bank, and we'll take a date. Let's say, what's today? 2025, 10/29. There we go. And I believe that takes care of that. All right, let's change this one. New TX, comma, my mom gave me the money, and she did it on, I don't know, 10/22/2025. There we go. And then one last one. New TX, 25. And I want to make a quick change here, but let's say this is our repair. And this was on 24, 2020. Oh boy! And notice I did my date formats backwards. Let's do that. 52024. There we go. All right. So I think we're ready to at least try it. So let's try it. Let's try to run our program. Let's just see what happens. And look at what it says. It says cannot be resolved to a variable. See that? At account deposit. It cannot be resolved to a variable. Right? So he's complaining about this guy right here. So he's mad at that account.java file line number 10. So let's flip over here. We'll hide this. Let's go over to account. Line 10. He says, oh, look at that. So what did I forget to do? I forgot to add the amount. Okay, so let's add that. And we can't get the amount anymore. We have to say get amount. And we have to do the same thing down here. Whoops. Get amount. All right, let's try this again. Maybe that fixed it. Ooh, look at that. Now everything's back to working. Let's make a quick change to our app. Instead of a deposit, let's make this a withdrawal. Withdrawal also takes a transaction. So now when we run this, we should get a different value, and we do. Right now our balance is $125.50 because we had $200.75 and then we subtracted 25. So everything looks good. What I want to do now is I want to actually make this part a little bit more, have more information, which is why we went through the trouble of creating this TX object. So let's go to accounts and let's go to the report. What we want is in history, we no longer want to just store the amount. Let's just store the entire transaction. So rather than making history a list of double, let's make history a list of transactions. And then we can just simply add this to history. Now, that means we have to change our report, I believe. Maybe not. Yes, it does. Yes, it does. We have to change our function here because now we're actually going through a list, not a list of doubles, but a list of transactions, right? And now, instead of the amount, let's change the name of it. Let's do TX. And let's do tx.getAmount. All right, let's see if everything still works. Go back to Java, run this guy. Sure enough, it still works. Only now what we'd like to do is get a little thicker representation of a transaction. So we could go here and add all the extra pieces here when we print it out. But that seems, I don't know, it seems like a weird place to do it. Let's try something different. Let's actually tell the transaction how to print itself. Let's create a function in the transaction object that knows how to print itself. So let's make it public. It returns a string, and we're going to call it toString. And here we're going to return a string. Return string.format. So the date, right, %s, and the what, %s, and the amount, %.2f, and then we'll pass the amounts. So we'll pass the date, the what, and the amount. There we go. So now we've told transaction how to print itself. I don't have to repeat this over and over and over again. It just automatically knows how to print itself. Let's go back over to the main. Actually, let's go back to account, and in our report, rather than do our own formatting and pull the pieces out ourselves, let's change this to println tx. Now wait a minute, you say, why don't I have to put .toString? Why don't I have to do that? Well, let's try to run it and see what happens. So let's go to my main and let's run this guy. And look at that. I now get this new, each transaction has the date, the what, and the amount. So what is actually happening here? Well, what's happening is that the transaction object has created this toString method. What you're witnessing is the fact that all objects in Java have a base class of capital O object. Capital O object is kind of the root class. Now, the way they talk about this is when you talk about a subclass, you're talking about you inherit something from something else. So the class you're writing is the subclass, and the class that you're inheriting from is called the superclass. An object is the superclass of all objects in Java. So because object has a toString method, all objects by default are going to get a toString method. An object has a default implementation of the toString method, which usually involves dumping out the hash number of the Java memory address of where that particular instance is stored. So by me adding a toString function to my class, I'm now overriding the capital O object's implementation of that. So we're talking about inheritance here, and we're talking about overriding that inheritance. So because of that default toString method on every object, because Java knows that every object, no matter where you defined it, has a default toString method, what that means is that if you just put the object itself in the print statement, that what Java's going to do is Java's going to implicitly just call the toString method. It just knows how to do that based on where it appears here. The compiler's pretty smart. It knows how to do it, so it's going to take care of it for you, so it makes it nice and easy. So what we're really talking about is this concept of inheritance, which is very prevalent in Java and used all over the place because it's actually quite useful. So let me show you a place where this is actually quite useful. I don't know if it's still, it's not still in the buffer. So let's do this. Let's do this. Let's go back to our main and let's run our main again. And here's what the report is currently printing out. And notice what it doesn't do is it doesn't really give you any kind of feeling for whether this is a deposit or if it's a withdrawal. Well, that would be nice to know. Now, we've done that in our account by actually, whenever we call the appropriate method, we've actually forced it to be a negative or a positive value based on whether we call deposit or whether we call withdrawal. Well, you can do that. That's one way to do it. But just for the purposes of illustration, let's say that the transaction object itself is somewhat aware of whether it's a deposit or a withdrawal. So we can do that very easily by using inheritance. So let's use inheritance, right? Let's use our transaction, and let's use transaction as our base class, right? As our super class. And we'll create a deposit version and a withdrawal version. So let's go here and let's create a new file. Let's call this deposit.java, right? And at the same time, let's just call this. And let's say that we're going to extend tx. So what this says is, look, everything that a transaction does, I want a deposit to do as well, right? But I'm going to do something, I'm going to add something a little bit different here. But first, let's just go back here and let's add the other side. So let's add withdrawal with, actually, I don't have to cap, withdrawal. Right? So now I've got a withdrawal and I'm going to, I'm going to extend or inherit from TX. So now, now I have a withdrawal and a deposit that extend TX. So why is this complaining? It says implicit superconstructor is undefined, right? So it says, you know what? I don't know how to build one of these guys. So what my IDE is complaining about is the fact that it needs a constructor, right? If you hover over this, it'll tell you, hey, I need a constructor for this guy. Because your TX doesn't have a default, just like toString, the constructor could have a default constructor and then this wouldn't be warning you. But since there is no default constructor, you're getting this warning. So you can fix this very simply by, put your cursor or, move your cursor over where the red line is and then hit Command period and it will tell you, hey, add a constructor because we just want to use the same constructor, okay? And then what that's going to do is that's going to call your superclasses constructor, right? Which takes the amount, the what, and the date, right? Pretty simple. Now, we want to do something a little bit tricky here, right? So let's change this thing where the amount, let's go back and we need to do the same thing for deposit. And let's go over here and say, hey, generate this constructor, right? All right, so now we've done the same thing. Now we have two classes. So now let's go back over to our main. Where is main? Where did main go? Here's main, okay. And this time, let's give these a new, instead of a transaction, let's give it a new deposit, right? And this is a new deposit. And this is now a withdrawal. So all we've done is we've made these objects more specific, right? They're not just a generic transaction. They now have an intended purpose. The purpose is this is a deposit and this is a withdrawal. So at this point, should we expect that our app is going to work the same way? Well, let's run it and see what happens. And sure enough, it does. It works exactly the same. However, I still don't have any feedback in my history listing of whether it's a positive or a negative value. So let's go back and let's fix some of this. So with a deposit, we can say, you know what, let's leave the deposit alone. The amount is the amount. But if it's a withdrawal, what I'm going to do is I'm actually going to make this the negative of the amount. Now, let's go back to main. Now let's run. And if I look at the run, notice now that now my withdrawal is a negative amount. Now there's something you should notice is that, now that the actual transactions are more specific, they actually indicate what they are, we actually don't need two separate functions to do the same thing, right? Now the function can take either one of these and perform the correct action because the object itself, the deposit knows it's a deposit, the withdrawal knows it's a withdrawal. So let's change accounting to change that fact. So all we really need is one single function that does both, and it just takes a transaction, right? It'll take both, right? But now the question is, well, how does, let's come up with an interesting name here. Let's just call this apply. Actually, let's use an official banking term. Let's post. Let's post this transaction, okay? Now the question is, how do I know whether to do a plus or a minus? Well, that's pretty simple. That is pretty simple. Now that I'm getting a value, this is going to work. This, in theory, right? The TX is going to be negative if I withdraw, and it's going to be positive, right? So let's run this. However, we've now gotten rid of these two. We've gotten rid of the withdraw and the deposit functions. So now we have to go back and change our main, because there's no longer a deposit. There's now, let's do this post. And let's call this post. And rename this to post. All right, now let's run our guy. And look at that. Everything still works. My balance is correct. My history is right. Everything is good for this account. All right, let's make one final little tweak to our account. This isn't strictly necessary. I'm just doing it to give you some visibility and some practice in, manipulating this object-oriented code. This internal variable here, this balance, if you think about it, I can actually generate this balance from my transaction history. I don't really need to keep this guy around. So let's do this. Let's get rid of this balance value. I'm going to comment it out. And then what I'm going to do is I'm actually going to add a get balance method. So let's get down here. So public, and it's going to be a double, because that's what our amounts are kept as. Get balance. And you know what? I'm just going to call it balance. So as stated, I can actually I can compute the balance just based on history. So let's do that. So let's do double results. Actually, let's call it balance. Equal to 0. And then I'm going to say for TX, I can't use in, sorry. Getting my languages confused. All right, so for every transaction, now what I want to do is I want to compute the balance. So balance TX dot amount. And then I'm just going to return the balance. All right, let's run and see what happens. And look what it says, unresolved compilation. Balance cannot be resolved to a variable. So I did not refactor out the whole balance thing. So let's go back to account line 9. So account line 9, there it is right there. Well, guess what? I got rid of balance. Well, guess what? I don't even need to do this anymore. I'm just going to get rid of it. Let's go back to main, run it again. And, oh, look at that, unresolved compilation. Now there's another at 15. So let's go back to account line 15. And sure enough, now balance isn't there. However, I now can call the balance function. Go back to main, run me. Hey, look at that. We're back to working, and it works correctly. So now we've kind of run through some of the basic premises of inheritance and encapsulation. It's really not difficult. you just have to work with a little bit and learn to structure your code accordingly.